CBSE Class 10 Math, video solution to the sample paper given by the board for the board examination to be conducted in 2021. This is a standard version of the paper. We are looking at a 3-mark question from the chapter Triangles. This question is question number 30. It had an internal choice. We did a separate video for the first part. This video comprises solution only to the second part. Let's take a look at the question. In an equilateral triangle ABC, D is a point on side BC such that BD equals 1/3 of BC. Okay. What we need to prove is AD square times 9 is equal to 7 times AB square. Triangle ABC is an equilateral triangle. All three sides will measure the same. AB equals BC equals AC. Let's say that measures A units. Now it says that BD is equal to 1/3 BC. BD is equal to 1/3 BC given in the question. The next step that I am going to be doing is basically I am going to drop a perpendicular from vertex A to the opposite side BC, which is nothing but the altitude to side BC. So draw perpendicular, we will call it as AE. AE is perpendicular to BC, right? It's the altitude to side BC. I'm going to establish something. What I'm going to establish is that E is the midpoint of BC. How are we going to do it? We're going to be using the properties of congruent triangles. Let's take a look at these two triangles, AEC and AEB. Both AEC and AEB are right triangles. Both the triangles are the same hypotenuse, and the measure of the hypotenuse is the same. AC, AB both measure the same A, therefore the hypotenuse is the same. AE is a perpendicular side to AEC, AE is a perpendicular side to AEB, which means both these triangles, one of the perpendicular sides measures the same. So by RHS, we can establish that these two triangles are congruent triangles. So we drew a perpendicular AE to side BC. By RHS, we are establishing that triangles AEB and AEC are congruent triangles. Now that we have established that these two triangles are congruent triangles, by the property of corresponding parts of congruent triangles being equal, BE and EC are the corresponding sides of these two triangles. BE will be equal to EC, right? We have established congruence. So now by CPCT, we can say BE is equal to EC. If BE is equal to EC, then E is going to be the midpoint of BC. Therefore, BE and EC will be equal to half of BC, which we can write it as half of AB, because all sides of an equilateral triangle are the same. BC is the same as AB. So BE is equal to half AB. We have established that. Now, we are trying to prove something between AD and AB. AB and AD. First look, it's quite evident that I have two right triangles AEB and AED. AB and AD are the hypotenuse respectively of these two triangles. So let's apply Pythagoras theorem on both these triangles. Let's start with triangle AEB, right? Triangle AEB is a right triangle. Let's apply Pythagoras theorem on it. Hypotenuse square, which is AB square, is equal to sum of the squares of the other two sides, AE square plus BE square. We have found out that BE is equal to half AB. Let's just plug that in here. So AB square is equal to AE square plus half AB the whole square. Half AB square is nothing but 1/4 of AB square. Let's take it to the left hand side. So AB square minus 1/4 of AB square is equal to AE square. Essentially, a number minus a quarter of the number is 3/4 of the number. So we can say AE square is equal to 3/4 of AB square. I'm going to call this as equation 1. Right? From right triangle 1, we have established Pythagoras theorem. We have basically applied Pythagoras theorem. AB square is equal to AE square plus BE square. We established that BE is equal to half BC, which is equal to half AB. So replacing BE as half AB, and we finally found out that AE square is equal to 3/4 of AB square. We'll recall this whenever required. Let's apply Pythagoras theorem on the second right triangle. This is equal to 1/3 of BC, which is nothing but 1/3 of AB if you want, right? Because BC is equal to AB. Now, right triangle AED, we are looking at it. AD is the hypotenuse. So AD square is equal to AE square. We have got AE square. Look at this one. AE square is one side. So we'll got the AE square here. Plus, what do we have here? AE square plus DE square. I'm going to try and write this D in terms of some things that we know, right? So AD square, we'll keep it on the left hand side, which is AE square plus DE is nothing but BE minus BD, right? DE is equal to BE minus ED, BE minus BD, right, whole square. So this is AE square plus BE is equal to half BC, BE is equal to half BC, which is half AB, right, minus what is BD? BD is equal to 1/3 of BC, we have said that is equal to 1/3 of AB. So 1/3 of AB the whole square. So in triangle AED, AD square is equal to AE square plus DE square. DE is written as BE minus BD. BE is half of BC, therefore half of AB. BD is equal to 1/3 of BC, which is 1/3 of AB, because all three sides of an equilateral triangle are the same. Half AB minus 1/3 of AB is equal to 1/6 of AB. So this is AE square plus 1/6 of AB square, which is 1/36 AB square. This is equal to our AD square. I'm going to keep AE square on one side. So AE square will be equal to AD square minus 1/36 AB square. This is equation 2. Let's go back to equation 1, right? Equation 1 is AE square is equal to 3/4 of AB square. Now we have equation 2 where AE square, the same AE square, right? AE square is equal to AD square minus 1/36 AB square. Because AE square is common on both sides, we can equate the right hand sides from 1 and 2, from 1 equal to 2. What we have is 3/4 of AB square is equal to, just make sure that you're writing it right, AD square minus 1/36 AB square. Take this 1/36 AB square to the left hand side. So 3/4 AB square plus 1/36 AB square is equal to AD square. Look at it. Now we have got it down to in terms of AB square and AD square. All other variables have been removed. 36 is a common denominator, so that will make it as 9 times 3, which is 27 plus 1. 28/36 AB square is equal to AD square. 28/36. Both of these numbers are divisible by 4. 28 is 7 times 4. 36 is 9 times 4. 7/9 AB square is equal to AD square. Cross multiply this 9. 7 AB square is equal to 9 AD square, which is what we have to prove, right? So essentially we started by establishing that when I draw a perpendicular AE, E is the midpoint of BC. From there we said we are able to look at two right triangles, AED and AEB, applied Pythagoras theorem on both the triangles, established all of them in terms of AB. So we got it down in such a way that this AE square can be written in terms of numbers which we will have to prove, which is AD and AB, and finally proved that 7AB square is equal to 9AD square. Before you leave, I want you to do two things. One, sign up at online.maxtute.com to get started with CBSE Class 10 Math online tuitions. It takes all of 5 minutes and less than 3 steps to get started. And second thing, I want you to subscribe to this channel and turn on notifications so that you get notified every time a new video is uploaded. Spread the word about this channel to your friends and classmates.